Well, first session, I hope you enjoyed your lunch. So I'm Felipe Gonzalez, first time in UIST, happy to be here. Yeah, closer, okay, here's good. Okay, so on behalf of my colleagues, I'm going to be presenting, facilitating the parametric definition of geometric properties in programming-based CAD. So let's start by framing the framework, the background of our project. So basically what we mean with programming-based CAD, we refer applications that allows users to describe models through programming language, basically exclusively in code. So normally these applications provide a code editor, either text or graphic, and a viewport for users so the users can validate the result. These applications normally brings value features and into the CAD field, which something like precision, the ease of perform repetitive actions, abstractions, and version control. So when you're doing a design, you need to define geometric properties, which can be defined with raw numbers, but this is not always convenient because if you need to modify the model, you need to redefine each one of the dimensions one by one. So basically that's why we use what we call parametric design, right? So in parametric design, you can define and relate the different geometric properties using variables and arithmetic expressions. So it allows rapid modification, abstraction, reusability, and it's very convenient for customization and sharing specifically in 3D printing, which is our area, but in general. So when you're doing parametric design in programming-based CAD applications, normally you need to define positions, sizes, dimensions with arithmetic expressions, which is not always trivial for everyone, right? But for instance, here the highlighted part is defined. The position of the highlighted part in the slide is defined with the line 65. So it's not always easy to derive such expressions. Interestingly, if you're about to place that part and you want them to be parametric, it's very likely that you want that part to be related with the spike next to it, right? So for the parts that are already in the view, the application already has all the information. So the user, if the user could actually retrieve this information, would be much easier to place new elements parametrically without the need to go through the whole process of deriving arithmetic expressions. So this is where we stand, basically. So our question is, how can we facilitate the definition of geometric properties of models in programming-based CAD applications? So we started with doing a formative study. With the results of this, we proposed some design goals and implemented them. And after that, we tested our solution with a user experiment. So in our formative study, we analyzed 30 OpenSCAD models from Thingiverse, which is a website that stores OpenSCAD models for sharing. And we took different models under different search filters, and we analyzed them. So basically, we modify OpenSCAD to analyze two types of code statements, spatial transformations, and primitive shapes. So the code, basically OpenSCAD, what it did was going through the code and counting and categorizing the different definitions under 5 categories, which are raw numbers, single variables, linear combinations of variables, polynomial expressions, and complex structures. So basically they went to the different statements and count. That was with it. So our results suggested or showed that first, scaling is an unused transformation, with something that we expected because dimensions are all normally defined in the primitives definitions. Rotations, most rotations transformations are raw numbers, which can suggest that it's difficult for users in programming-based CAD to perform more complicated transformation when you are rotating objects. And most importantly, that most of the primitive definitions and translated definitions fall into the C1, C2, and C3 categories, which are basically linear combinations, single variables, or raw numbers. So what do we have? We have that geometric properties are related in a linear combination of variables. Applications already have the information to support geometric definitions, and the view presents an easier way to see, to understand the model. It's much easier to know where a position is in the view than going into the code and understand the code to know where in the code do I have to create or to modify the model. So our objective is to facilitate the extraction of parametric information from the view to reuse it in the code. So for that, we use OpenSCAD, which is arguably the most popular programming-based CAD application, which use CSG. So CSG modeling, in CSG, you don't have actually information about the vertices, edges, or faces. So we redefine the primitive, adding some selectable handles in points of interest. So this is how they look like. You're going to see them in the next slides as well. So normally, what happens in OpenSCAD is that OpenSCAD parses the code into an abstract syntax tree that creates later a geometric tree, and after that is rendered in the view. In the process, normally OpenSCAD evaluates the value of the variables and keeps only the evaluated values just as numbers. So we modified the OpenSCAD to also allow different nodes to also keep the information about the definitions using with the used variables in the code. So when the users interact with a specific handle, each node is capable to actually retrieve the information of the variables used in its definition and iterate backwards in the tree, so we can identify other transformations to finally get the global position. So with this, we implemented two features. The first one is position features, which you can allow with the button that is placed in the menu bar. So normally now you can select an object, and when you select an object, the handles are displayed. And when you right-click on one of them, the system calculates the definition, parametric definition, and it starts in the clipboard. So then you can use that definition going into the code to define the position of new elements, just as you see in the. You see that the definition is based on the variables that they were used in the definition of the first part, and you can go on that. So with this, the user doesn't need actually to go through the code to understand it completely to place a new element parametrically. So this is the first feature that we implemented. The second one is delta vector feature, which follows the same principle. You can enable it by pressing the button in the menu bar. But now this allows me to align two handles of two objects. So I first select the object that I want to move, and then I select the object that I want to have as a reference. I click on both handles. And when it turns green, the definition of the transformation that I need to derive is placed in the clipboard. So I can create a code statement to move the element and align the handles parametrically, of course, which is the objective here. So you see now we have placed four legs in this box, and if I change the values of the parameters, the structures maintain the model keeps the structure. So after that, well, we tested our solution. We recruited 11 participants, in average 44 years old, with more or less 9 years of experience in 3D design, and all of them with programming background. And we asked them to replicate two parametric models with the original and modified version of OpenSCAD. We recorded the screen, and after the experience, we asked some user experience questions. So we report our results in terms of performance and user experience. So overall, participants expressed that the features would facilitate the design process in general. We also asked them if they were easy to use, and although most of them answered yes, from yes or most likely, we found some usability problems in terms of the using right-click instead of left-click, the workflow using delta vector, the order that they had to follow in order to like first selecting the one object, after that the other one, and so on. In terms of performance, we found that the users needed proportional fewer attempts to succeed, and also made fewer errors using the features. But we also noticed that when they made a mistake, it was hard for them to go back. They didn't know exactly where was the problem and how to fix it. In the questions, we found that participants thought that this type of solutions could ease the entrance for newcomers, speed the process up, and avoid math errors in general. So in conclusion, well, we start with a formative study to understand how geometric properties are defined in this type of applications. Based on these findings, we proposed the design goals to facilitate the definition of geometric properties and implemented them in a real programming-based CAD application. And we tested our solution, finding that it could facilitate the design process, could facilitate the entrance of newcomers, and in general improve the user experience. So that's it. Thank you.
If you have any question, please walk up to the microphone.
Hi, thanks for your talk. So I'm aware that like there are sort of constraint-based CAD software that uses GUIs to like build persistent constraints, and it sort of seems like some of your GUI things are implementing a similar thing. So I'm curious, like, I can imagine extending OpenSCAD to have some sort of like constraints as a first-class thing. Have you explored that, or like what might be the challenges for maybe adding like, I don't know, joins or some types of constraint primitive to OpenSCAD?
Yeah, sure. Well, there's a fundamental difference with constraint applications, right? In constraint applications, you basically throw different rules that you want the application to solve. And so basically, you're telling the application what you want. In programming, you say how you want it. But just coming to your question, yes, actually, we're working right now in a project allowing users to have sort of constraints in a different panel. So you can select, for instance, I want this distance to be exactly that value, and then the system with some restrictions, because the idea of programming based, or one of the valued features, is that user has control. So you don't want to lose that control. So with some limitations, the idea is to allow users to do this type of constraints, and without the need to losing control. So just in brief, yes, we are in that direction.
Cool, thanks.
Hi, I was just curious about the user study. What was the order in which they tried to replicate the models? Was it they did it with the assistive parametric first, or was it the other way around?
Okay, so the models were randomly assigned, balanced assigned, but they always started with the original version of OpenSCAD. And the reason for that is that all of them were very experienced, so we didn't think we were going to have a learning effect in the experiment. So the first part was trying to establish a baseline, and then after that they used the features when they felt they could or wanted. So that was kind of difficult, because they, at the beginning, this is a different paradigm. This is one of the limitations, actually. We think they need more time to get used to that, because we have seen that programmers, they tend to do everything in code. So when you tell them that actually you can use the view to get information and put it there, is not something that they accept easily. So, but the order was first without, and after that with our features.
And if you are going to expand user study, would you also kind of explore how it was used in kind of a population of designers that were somewhat familiar with math, and then, you know, but mostly kind of an artist background, or would you do any exploration in that space?
Well, actually, we have another paper related to the challenges of programming-based CAD applications, and you see that most of them are people that already had a programming background, and some of them have had some, let's say, direct manipulation applications experience. But it's very weird to find people from the, let's say, creative, I don't want to say creative, but more design part using this application, which I think is normal, because programming is a high barrier for people to entry, and which is one of the objectives of this type of project, is to allow people to not worry that much about the technical aspect.
Thank you.
You're welcome.
Right, that's perfect. Thank you so much, Felipe. Let's give another round of applause.